Hello, Ante Matrics. So this is your walkthrough of the test that we did on the 22nd of February. Memo is available on Teams, but in this video I'm just going to focus on some of the strategies that you should be using at each question. Alright, so for question 1, question A, solve for x. Leave your answer to 2 decimal digits. Do not use the equation mode on your calculator and show all working. So the clue here that you have to be factorizing using the quadratic formula is the fact that they ask you to leave your answer correct to 2 decimal digits. So in any quadratic equation, we want to equate all of our values to 0. All right? And at the same time, making sure that our equation is in standard form, i.e. in the form ax squared plus bx plus c. All right, so I've equated my equation to 0, and now I can substitute into the quadratic formula. All right, recall that the quadratic formula is x equals minus b plus minus the square root of delta, or b squared minus 4ac, all over 2a. All right, so I'm going to substitute the values into that equation. So x equals negative 7 plus or minus b squared, which is 7 squared, minus 4 times a times c, and that'll all be over 2 times a, which in this case is 5. All right, now if the question had asked you to simplify to simplest third form, then your answer will be the next step, okay, where we simplify inside the delta, and we get a 29 inside the delta, and underneath it remains 10. Okay, it's always a good idea to put your answer in simplest third form anyway, and then if it asks you to go to 2 decimal digits, then your next answer would be to 2 decimal digits. So you're going to plug this whole expression onto your calculator, first using the plus sign, and write down your answer, and then go back and edit your input into the calculator, and then use the minus sign. So with the plus sign, we get x equals negative 0,16, and then when we edit and replace it with the minus sign, we get minus 1,24. Please consult the memo on Teams to see exactly where marks were allocated, and I'm not going to focus on where the marks are allocated in this video. We're just focusing on how to do the work. Right, question B is clearly a quadratic inequality. We know it's an inequality because there's an inequality sign, and we know it's quadratic because you can see straight away that if you multiply those two brackets out, you're going to have a expression with x squared in it. All right, so we follow the rules as per quadratic equations. In this case, we need to FOIL out because there isn't a 0 on the other side. There's a 12. So we're going to FOIL out the left-hand side. So we get x squared. Then out is minus 1x minus 5x is minus 6x. And negative 5 times negative 1 is positive 5. Take over the 12 and less than or equal to 0. You could have done this in one step, because x squared minus 6x minus 7 is then the left-hand side in standard form. All right, now factorize your x squared minus 6x minus 7, and we get x minus 7, x plus 1 is less than or equal to 0. All right, now please, one mistake that often is seen is that after this step, you write x equals 7 or x equals negative 1. Remember, it's not an equation, it's an inequation. So x can't equal those values, all right? Sometimes those values can be included in the solution, but by stating x equals 7 or x equals negative 1, you're saying it's only those values. So what you can do is you can say critical values at x equals 7 and x equals negative 1. That is fine. Okay, I prefer to go straight to the number line, all right? So we've got negative 1 as our first x value, and we've got 7 as our second x value. All right. So looking at this step, we can see, well, any step, but this step, because it's been simplified, we can see it's a positive parabola. So I draw a positive parabola on my number line like this. And we can see that we're looking for the negative solutions. In other words, the solutions that are less than 0. Okay, so these are the solutions that are less than 0, between negative 1 and 7. And we can include negative 1 and 7 because it says less than or equal to 0. Right, so our answer then is that negative 1 is less than or equal to x, which is less than or equal to 7. And another way of saying that inequality is x is between and including negative 1 and 7. All right, question 2. Solve for x and y. Y minus 5 equals negative x, and y equals x squared minus 11x minus 19. Right, so what I'd like you to realize here is that you've got a straight line function. Right, there's the straight line function, and you have a parabola. All right, so now you won't get two parabolas to solve simultaneously. You'll get a straight line and something else. So it's always easiest to work with the straight line function first and make either x or y the subject of the equation. All right, so in the memo that I put on Teams, I made y the subject of the equation. So in this video, I'm going to make x the subject of the equation, just in case some of you did that in the test or tried to do that, and then you can see what the correct solution to that would be. All right, so I'm starting with y minus 5 equals negative x. I'm going to bring the x over to the left-hand side to make it positive, and I'm going to take the negative 5 and the positive y over to make it 5 minus y, and then this is my equation 1. All right, equation 2 is this one. Just incidentally, in this case, it actually is easier to make y the subject of the equation because the second equation is already with y the subject, so you would just need to equate the two equations. All right, but just to carry on, I'll still show you how you get the same answer with just a little bit more work. All right, so we substitute equation 1 into equation 2, and you need to tell the markers which are your equations and which ones you're substituting in when. All right, so in equation 2, wherever we see x, we're going to replace it with 5 minus y. So y is equal to x squared, so that's 5 minus y squared, minus 11 times 5 minus y, minus 19. All right, and now we need to FOIL out. Okay, so y is equal to 5 minus y FOILed will be 5 squared is 25, minus 10y plus y squared, and then distribute the negative 11, that gives us negative 55, plus 11y minus 19. All right, and so now you see we've got a quadratic, so we just need to tidy up into standard form. Right, so I'm going to equate to 0 and collect our terms. So we've only got one y squared term, all right, but we've got minus 10y plus 11y is positive y. Okay, minus 10 plus 11 is positive y. And if we then take over this y, the y cancels out, and so we don't have any y terms. Now our constants, we've got on this side, we've got 25, we've got minus 55, and we've got minus 19, which all simplifies to minus 49. All right, so minus 49. So this works out quite nicely because it's a difference of two squares, and we can factorize accordingly. So y minus 7 into y plus 7, then that means y is equal to 7, or y is equal to negative 7. All right, and then you can find your corresponding x values by substituting this 7 into that equation, your first equation. All right, so 5 minus 7 is negative 2. So what that means is when y is 7, x is negative 2, and then we substitute negative 7 into the same equation. So 5 minus negative 7 now becomes 5 plus 7, which is 12. So when y is negative 7, x is equal to positive 12. Okay, question 3b. Given that x equals negative 3 is one root of the equation, 2x squared plus kx minus 15 equals 0, determine the value of k and hence the other root. So we must determine the value of k first. I noticed when marking that some people were trying to factorize it first, but the question said determine the value of k and then the other root, hence the other root. All right, so we first have to substitute x equals negative 3 into our equation. So we get 2, let me change my color. Okay, we get 2 into negative 3 squared plus k times negative 3 minus 15 equals 0. All right, so simplifying this, negative 3 squared is 9 times 2 is 18, minus 3k minus 15 equals 0. So 18 minus 15 is 3, and if we take the 3 over to the right-hand side, it becomes negative 3, and so that means the value of k equals 1. Alright, so secondly, and I'll do this on the right-hand side here, we now know that k is 1. So we can replace k with 1 in our equation, 2x squared plus 1x minus 15 equals 0, and now we can factorize. Okay, factorizing is easy here, even though the coefficient is not 1, because they've already given you one root. So we know that if x equals negative 3 is a root, one of our brackets needs to be x plus 3. Alright, and so now we can just use inspection to work out what the other bracket is. It needs to be 2x minus 5. Alright, and why is that? Because we know that x must be multiplied by something to get 2x squared, so therefore that's 2x. And we know that 3 must be multiplied by something to get negative 15, so therefore that's negative 5. Okay, question 3c. Given 3x squared plus t over 4 is equal to 5x. Alright, determine the values of t such that the roots of the equation are 1, real. Alright, so remember, the moment you are seeing when they want you to determine values that influence what the roots are going to be, we are always going to be working out delta. Alright, because we know our rules for delta apply to when values will be real, non-real, rational, equal, unequal, and so on. Okay, so before we can use delta, we have to have our equation in standard form. So let's work with me here and bring over everything to the left-hand side of the equation. Alright, so 3x squared minus 5x. I'm putting the minus 5x first. Remember, ax squared plus bx plus c. And then our plus t over 4, which is the constant. Even though there's a t in it, it is a constant. And now we can then equate to 0 and then substitute into delta. Alright, so delta is equal to, and again with delta, please do not put the square root sign. The square root sign is not part of delta. Delta is underneath the square root sign. Alright, so delta is b squared minus 4ac. Recall, I'm just going to put the formula here, the inside of the third in the quadratic formula. So substitute delta in, we get minus 5 squared minus 4 times 3 times t over 4. Okay, b squared minus 4ac. And that simplifies to 25 minus 3t. Okay, then for real roots, and you must state this, for real roots, delta must be greater than or equal to 0. Alright, so you're then going to make your delta greater than or equal to 0. Okay, so that means that 25 minus 3t must be greater than or equal to 0. And now you solve for t. So we will take over the negative 3t to get positive 3t, and then divide both sides by 3. So 25 over 3 and t on its own. So this says that t is less than or equal to 25 over 3. Alright? Now, for question 2, it's only 2 lines, but only 2 marks, but only 1 line to do it. And we wanted you to see that all numbers that are not real must be non-real. So if they've asked you in question 1 to determine the values of t such that the roots of the equation are real, and we've gotten that t is less than or equal to 25 over 3, it then follows that the ones that are not real will be the opposite of that. So therefore not real here is that t is greater than 25 over 3. Right, that's the end of section A. Section B, question 4. Draw a rough sketch of the graph of y equals ax squared plus bx plus c if delta equals 0, a is less than 0, and any roots are negative. Okay, so there's several things going on here. Alright, and I'm going to look at each of them individually before we sketch. Okay, firstly, this tells us that the graph is quadratic, so we know it's a parabola. Alright, so a parabola has either this shape or it has that shape. Alright, the second thing is that they tell us delta is equal to 0. If delta is equal to 0, think what that tells us about the roots. They are equal. Alright, that means that the turning point is on the x-axis of our parabola. All right, because if you had to think about factorizing a graph like x squared, x minus 3 all squared, your solution has two brackets that are x minus 3. So in other words, you've only got one x-intercept, so the only way a parabola can have one x-intercept is if the turning point is on the x-axis. Okay, so this tells us it's a parabola. This tells us that the turning point must be on the x-axis. This, a is less than 0, they're referring to that a, tells us that the graph is a negative parabola. Okay, so in other words, that's the shape that we want. All right, so let's see what we've got so far. We know that the graph needs to be a negative shape. We know that the graph has to turn on the x-axis. All right, and the only way that a negative parabola can turn on the x-axis is if the parabola is below the x-axis. Okay, so for your first mark here, you could not have drawn your parabola anywhere above the x-axis in quadrant 1 or 2. Okay, but then there's one more condition that they give us. They say that any roots are negative. Now we know there's only one root. It's where it touches the x-axis. So the only place where roots are negative is to the left of the y-axis. Okay, so that means you could have drawn your parabola anywhere on the left-hand side, provided that your turning point touched the x-axis. Okay, it didn't matter whether you had your parabola cutting your y-axis. You'll see in the memo on Teams, my parabola doesn't cut the y-axis anyway, apart from what you can see. But as long as the turning point is on the negative x-axis, as long as the graph is negative, and as long as the graph is below the x-axis, you'll get the 2 marks. Question 5, the word problem. By traveling 10 kilometers an hour faster than its normal speed, a train can complete a journey of 300 kilometers in 1 hour less. Determine the train's normal speed. All right, always let your variable be what the question's asking. Makes the end of the question easier for you to interpret. All right, so you're going to say let the normal speed equal x. All right, so with any of these distance, speed, time formulas, or problems at least, you're going to use a table. And in our table, remember, we've got 3 parts to it. We've got our distance, we've got our speed, and we've got our time. And we also have 2 different situations here. We've got his normal speed, and we've got his faster speed, all right, where he was traveling 10 kilometers an hour faster. All right, so now you've got to populate the table with the information that we've got. We've said let his normal speed equal x, so therefore we need to have an x in that column. All right, and then the question says that his faster speed is 10 kilometers an hour more than his normal speed, so therefore this speed of the faster time will be x plus 10. They also tell us that the distance is 300, so that will be in both rows for the normal and the faster time. All right, the distance remains the same. Okay, and then in these questions, you're always going to use your third column. You're going to use the 2 columns that you filled in to work out your third column. All right, and then knowing that time is distance divided by speed, then in the time column for the normal, we're going to have 300 over x, and in the time column for the faster time, we're going to have 300 over x plus 10. Okay, so sometimes the trickiest part in these problems is setting up your equation. All right, so going back to the question, they said to us that the faster speed, when the train travels at that faster speed, they complete the journey in 1 hour less. So we haven't used that 1 hour yet. Okay, so what I like to do to make sure that you get the equation right is to set up our one speed, 300 over x plus 10, and on the other side we're going to have our other speed, 300 over x. Okay, now you've got to ask yourself the following. Which of these 2 speeds, remember we want to equate them, we want to make an equation where the left and the right equal. So in other words, which of them is the faster, which of them is the slower? This is the faster. Alright, so this is the faster one, and this is the slower one. Okay, so let's just think logically now. Let's say that if he traveled 10 kilometers an hour faster, now these aren't the actual answers, I'm just trying to give you an idea of how to work this out. Okay, it says that he traveled the one an hour less. So say now it took him 5 hours to travel that one. That was the faster one. Therefore, the slower one is 6 hours because that's 1 hour more. Right, so just to say that again, the 5 and the 6 are not the answers. It's really just for you to understand that there's an hour difference, and we already know that this one is the faster one. We worked that out there, and this one is the slower one. So if it was 5 hours to 6 hours, then how would we make this equation balance? Think of science students. We would have to add an hour to the left-hand side. Okay, so then that means this would be 5 plus 1, which then makes the equation equal. All right, so we're going to remove those made-up numbers that are made, because now we've got our equation and we can solve accordingly. Right, so we're going to multiply by the LCD. So the LCD in this case is x into x plus 10. Don't multiply your LCD out, right, because you're going to use it to cancel. All right, I'm just going to move my equation over a bit so I know I've got space, and then carry on. Right, so we're going to multiply everything by that LCD. If we multiply the first term by the LCD, can you see that the x plus 10 will cancel with that x plus 10? So actually you're left with 300x. All right, if we multiply the 1 by the LCD, the 1 is over 1, so we have to have the whole LCD, and here you can multiply it out. So it's plus x squared plus 10x. And then on the right-hand side of the equation, if we multiply 300 over x by the LCD, the x at the bottom there cancels with the x at the bottom there. And so you're actually just multiplying the 300 into x plus 10, which you can multiply out into 300x plus 3000. Okay. Sometimes I've seen that students at this point sometimes think they've made a mistake because 3000 looks really way too big. But remember, 3000 is the product of two factors in your brackets. So carry on. You are right. All right. So make your equation equal to 0. So we've got x squared plus 10x. It simplifies quite nicely because the 300x's on both sides cancel out. And then your constant, your 3000, you can bring it over to get negative 3000. And that equals 0. Now factorize. And you can use your calculator to factorize these big numbers. And x plus 60 equals 0. Therefore, x equals 50 or x equals negative 60. All right, we have to discount this solution, not valid, because we can't have negative speed. Even if you go backwards, the speed's not negative. So our solution is x equals 50. Therefore, the train's normal speed is 50 kilometers an hour. Okay, question 6. This was the question from your previous test. So in other words, you know for sure that this question will not be repeated in the next test, but any of the other questions in this test can be repeated and will be repeated in your next test. Right, so consider the equation x squared plus 5xy plus 6y squared equals 0. Solve for x in terms of y. Okay, when they say solve for x in terms of y, that means you first got to have your x on the one side and you got to have your y on the other side. Okay, so solve for x means it's going to say x equals and then whatever on the right hand side with your y. But then it said, and hence calculate the values of the ratio x over y. All right, so even the second time we did this question, there were still a lot of you that could not complete the question and calculate the values of the ratio. All right, so we're going to focus on that quickly. So first, the factorizing. All right, the factorizing part is easy. It's a straightforward FOIL factorization. All right, so we get x plus 3y and we get x plus 2y equals 0. All right, that means that x plus 3y equals 0 or x plus 2y equals 0. Okay, so x equals negative 3y or x equals minus 2y. All right, so that's where we would stop if they just said solve for x in terms of y. All right, but they want the values of the ratio x over y. So all you have to do for both of these is divide both sides by y. So you're going to have x over y. There's your ratio of x over y is equal to minus 3. And strictly speaking, it should be minus 3 over 1, because then it's a ratio of minus 3 to 1. And on the right-hand side, x over y is equal to minus 2 over 1. Question 7a, solve for x by completing the square, leaving your answer in surd form. Right, so with completing the square, and I'm aware that some teachers teach the method slightly differently. So the method that I teach now, if your teacher doesn't teach it like that, then please don't let me confuse you. But if it does confuse you, then just go back to your method. All right. So for completing the square, what I say is take over all the x terms. So we have minus px, and we have equal to positive 1. All right. We now need to divide everything by 2. Remember, one of the rules of completing the square is that your coefficient of your x squared term must be 1. In other words, your a value, if it's not 1, we need to divide it through into every term. Right, so in this case, I'm going to have x squared minus p over 2x. And now I'm going to leave a space for my extra term I've got to add in. And on the right-hand side, I've got 1 over 2. Okay, so I've divided everything by 2, and I've left a space here because we're going to add in our extra term. All right, so how do we work out that extra term? I'll do it on the side here. It's always half your b term. Remember, this is ax squared plus bx plus c. So it's a half times your b term and then squared. So in this case, our b term is negative p over 2. All right, so a half times p over 2. You don't need to worry about the negative, because when you square it, it becomes positive anyway. Okay, so a half times p over 2 actually gives us p over 4 squared, and that equals p squared over 16. All right, so that's our extra term that we're adding. So we're going to add p squared over 16, and we need to do it on both sides of the equation. All right, now on the left-hand side, we need to factorize. Now, it factorizes really nicely because you've made it a perfect square. So we know it's going to be a perfect square. All right, so the factorizing works like this. It'll be the square root of this term, which is x. Then it'll be whatever sign you have there, which in this case is a negative. And then it will be the square root of your last term, which is p over 4. All right, then on the right-hand side, we can get a common denominator of 16. And that 2 must be multiplied by 8 to get 16, so therefore we multiply the 1 by 8 to get 8 plus p squared. Right, in the next step, we want to isolate the x value, so we take the square root of both sides. So the left will just give you what's in the bracket, x minus p over 4. And on the right-hand side, the numerator is not a perfect square. So that's where we show the plus minus square root of p squared plus 8. Okay, but the denominator 16 is a perfect square, so we can write the square root of the denominator as 4. All right, and then our last step is just to take the constant that's still on the left over to the right-hand side. It has the same denominator as the right-hand side expression, so let me just make that better. We can put the denominator as 4 at the bottom and bring the negative p over, becomes positive p plus or minus p squared plus 8. Right, and that's in simplest surd form. Right, question B. The solution to a quadratic equation of the form ax squared plus bx plus c equals 0 is given as x equals 8 plus minus square root of 184 over 10. Okay, the key idea here is to use your quadratic formula. Minus b plus or minus b squared minus 4ac all over 2a. Right, now, so in questions like this, your starting point is to realize that you can match up your denominator 10 to 2a. Remember, we're finding a, b, and c. You can match up your denominator 10 to 2a, and you can match up 8 to negative b. So it doesn't matter which of those you do first. I'm just going to do a first because it's alphabetic order. That means that 2a equals 10. so therefore A must equal 5. All right? And then if 8 equals negative B, then B equals negative 8. All right, so now that you have the A and the B value, you can then substitute into the inside of the surd to solve for the C value. All right, so that means we know that 184 is equal to B squared minus 4AC, the inside of the surd. But we can substitute the values that we already have, and that is for B negative 8, and for A is 5, and then we're solving for C. All right, so we can now say negative 8 squared is 64. And if we bring the 64 over, it becomes 184 minus 64, which is 120. And on the right-hand side, we have negative 20c. Now divide both sides by negative 20, and c is then equal to negative 6. Right, question C. Solve for x. X plus 3 all squared is less than 0. All right, there's no working out that you need to do here because there is no solution. All right, and let's look why. On the left-hand side, you've got a value that is squared. Now, you should know that if you square any number, the smallest value of that square that it can be is 0. For example, in this case, if x was negative 3, then negative 3 plus 3 is 0, squared is 0. But if x was any other value, you're always going to get a positive number. And this is telling us that it must be less than 0. So in other words, there is no solution. Question 8. Prove that if p and q are rational, the roots of p plus q times x squared plus x into minus p minus 2q minus 2p equals 0 are also rational. Okay, so this follows the form of ax squared plus bx plus c. Okay, where this is your a value, this is your b value, even though it says x times b, it's the same as bx, and this, including the negative, is your c value. All right, so they're talking about roots again, and I said earlier in the paper, when they talk about roots and rational and things like that, we know we're using delta. Okay, so into delta equals b squared minus 4ac, you need to substitute the values. Okay, so before we go, let's just see where we're going. They've asked us to prove that the roots of the equation are rational. All right, now for rational roots, we know that the inside of the surd has to be a perfect square. Okay, so we basically have to substitute into delta and try and prove that the roots are a perfect square. Okay, so let's go. B squared, right? The b value is minus p minus 2q all squared, and then we're going to subtract 4 times the a value, which is p plus q, times the c value, which is minus 2p. All right, let's FOIL out. So minus p times minus p is p squared, and then minus 2q times minus p is positive 2pq. Then the outers and inners are both 2pq, so that gives us plus 4pq. And then the last is positive 4q squared. All right, and then for the second part, we're multiplying these three terms together. So I always start with the ones that aren't binomials. So minus 4 times minus 2p is positive 8p. And then if we multiply positive 8p by p, we get positive 8p squared. All right, and then again, minus 4 times minus 2p is positive 8p, but we must multiply by the q now, so it becomes positive 8pq. All right, so at this stage, it looks like a bit of a mess, but you've got to now see what can you simplify. All right, and ultimately, we want to factorize, because if it's a perfect square, then we need to be able to factorize it as such. Okay, so let's look at your like terms. All right, you've got a p squared and you've got an 8p squared. So that gives us 9p squared. Okay, then you've got 4pq and you've got 8pq. All right, so we add those together and we get 12pq. And then lastly, you've just got a 4q squared left. All right, now that is a perfect square. And even if you don't recognize it as a perfect square, the question is telling you you've got to find a perfect square. So factorize it as if it's a perfect square, and then just check your answer. So with a perfect square, we know that the first term is going to be the square root of that term. So in this case, 3p. And then we've got to have a plus because the only pluses in this equation. And then the last term is the square root of the last term in the trinomial. So 2q, and we know it must be squared. Okay, double check yourself if you're not sure. So square the first term, we're going to FOIL it out. 3p all squared is 9p squared. Then the outers, 3p times 2q is 6pq. The inners will also be 6pq, which gives you 12pq. And then the last 2q times 2q is 4q squared. Right, so we have got a perfect square. So we're going to conclude, therefore, perfect square. And because of the fact that it's a perfect square, it tells us, therefore, the roots are rational.